Good morning, everybody. I'm here to present a learning and creativity plan for image classification, which is a task, traditionally a complex task, which is for a computer to see an image and to classify what is inside it. So we devised a learning plan that helps students work on these concepts from a low-code approach in which you can understand the basics of how these algorithms work, to approaches where they can actually, if they are programming students from any professional course, they can test their programming abilities if they desire, though it's not required. Okay. Okay. We devised this course for the 10th to 12th grades. We devised a set of activities that can be applied in conjunction or separate or even optional activities. Though the minimal time frame for this workshop would be 24 hours, but it would span for a project throughout the semester where students can autonomously work and improve themselves. So, this is intended to be, at first, demonstrative and active demonstration of the platform or the tool that we use to build and test these algorithms. But then we would like to invite students to be proactive and autonomous in their fiddling with the parameters, fiddling with the workflow, fiddling with even images. And although we alongside this learning plan, we devised a lot of support materials. The truth is that they can easily be substituted for support materials that anyone can replicate or imitate or adapt to their own situations. So, what we want to demonstrate is how machine learning models work, how they test images, and how can we create a model that can be applied and transferred to other tools or to other programs. So our requisites for the images are none. Well, at least they can be very different. They can be transparent and transparent. The image sizes can be completely different. There's no problem. And students will learn what they need to do in order for the computer to see them and to classify them. So they will have tasks to redimensionate the images, to categorize, to transform the images into numbers and bits and bytes, and how then to apply these algorithms. So this sounds scary for students because it might lead to them thinking in programming and to a lot of complex tasks. But there is tools like this one, which is 9, which are drag and drop with nodes, and they can produce a workflow of steps in order to go from an image to a classification. And it is this step that you can explore what these algorithms do. And here is demonstrated, cannot be clearly seen, but is demonstrated how to build a neural network layer by layer. Which is we can input the data and then build layer by layer, the input layer, middle layer. We can even try different architectures. And in the end, they will, the model will be trained and it will give outputs for each node. So the goal is for the student to understand why sometimes there are models that make the news because they are deemed as racist, because they cannot classify a certain race of people or gender, And most of the time, it's not because of the algorithm, because the data that was used in training. And this can be really exemplified if we pre-select the images and leave out one category. And then if you feed the algorithm with an unknown category, the algorithm will try to classify in some category that he knows, but it will be wrong. And if it is a problematic situation, then we can really demonstrate to students why these problems arise. And they will understand how a complete machine learning workflow is developed and is implemented. So these are the main outcomes. So they understand how models are built, what impacts their quality, what are common problems, and in a complex task we use classification. So we propose to students, to teachers, okay, that work in conjunction. These are teachers that will support presential activities, but we can also add this learning plan to project and seminary curriculum or independent project development.
So teachers with this special
Perhaps not, but with informatics, they can bring this. I don't know. They can make a seminar in which they can make this, and then autonomously develop the project.
So maybe others, but that means new projects develop teachers high potential for teachers to become experts in and machine learning workflow.
This is not the qualification, but the roles that they will.
That's why you don't need a degree. You can develop the so-called micro potentials to give specialization.
Yeah.
Actually, sorry. I think that here you could add another teacher from other areas so that they can combine in order to produce something more practical. For example, an issue that we face in another project is the use or the hunting data in the case of climate change. So if you combine all these three specialties, we could produce something that we have in just image classification in the case of applying that in data for climate change. I don't know.
Yes, it's definitely an interesting suggestion.
Because one of the major difficulties really, at least in the case of climate change, is how to really pass the message that are coming out of this huge data that you have to handle if you are going to reach practical results. And that's really where I feel that we could just reconsider this by adding a third feature or another area if we are going to produce something more concrete.
Okay.
Sorry.
That's an interesting. Well, they can. I think we can also integrate teachers from other areas. And usually nowadays, students have open seminars or projects that are throughout the year, and we can incorporate also those teachers to try to use these models in their final project, for instance. Well, but originally this learning plan was thought as a stage one, as a practical demonstration in which the teacher and the students are working with the tools, okay? And the stage two, which they are mostly autonomous, and the teacher is like a supportive, as a supportive role to give advice, to try to give hints to the students in order for them to improve solutions. Because in machine learning, having a solution is good, but the real work starts there, because it's the improvement of the model and to reduce the errors, and that's key. So we produce, like I said, some course materials that can be used or can be used to adapt to this reality, and they were prepared for the Windows operating system, but in theory they should work with anyone. And the materials go from the design, the whole program installed with all the plugins ready to be used, workflows in completed and completed, workflows which have all the nodes that are ready already on the drawing area, and they have to make them by order. We have sample images, we have troubleshoot guides that would help. So, and our proposal, this should be a very long workshop, but the initial part, the presentation of the context and the problem, which we discussed some theory related to assessment of machine learning, and then we can choose a low-code approach for students who don't know how to program, don't just to drag and drop certain nodes in a workflow, or if they know how to program or are studying programming, we can also let them program the nodes. And we in tasks C1 or C2, we can also devise levels. Okay, the first level, load the data. Second level, load and transform data. Third level, load, transform, and classify. We can go step by step in their learning path. And this either approach can be complemented with some competition using online platforms such as Kaggle, in which you can draw all the course materials, and they can try independently to build their models and submit their classifications to Kaggle and see how they rank in the class and try to improve each other. And task E would be autonomous exploration, where students would have to take pictures of something they want to classify and to do all the process autonomously to classify whatever they want, and they can then do a final presentation. So task A and B would be the presentation of context, what is machine learning, focusing on what is important for these tasks, so like model assessment, what are the steps that they are need to do, what is the algorithm that they will study. In this case, is neural networks, but it's nice to know what it is, and to demonstrate the tool and what it can do, where are the nodes, where you can link the nodes, and what you can do. In task C, they should be able to guide it or unguide it, at least in the first stage, with how to build a working solution, and from there on, leave the students autonomously to change parameters and to see and evaluate metrics that can be seen at the end of the workflow. So they can see that lines, okay, it represents learning accuracy in training and test phases, and they can compare with other students. And if they're using Kaggle, they can rank themselves and see who has better options. So if there are students that can code, they can, instead of drag and dropping, they can open a special node and drop the code inside, and they will also work in the same way. So for the cable solution, we provided some materials how to make a workflow that already produces a file ready to upload to the competition. We just revolve how to do the tasks like data preparation, data training, and classification. So they build the model development part, and the rest is already provided. And the task key, like I said, is completely autonomous. Can be a seminar, can be a week-long project for the students to autonomously go take pictures, go arrange the pictures, translate, apply similar workflows as the ones they were developing in the workshop, and having as a background another competition throughout the time that they have to develop this activity. It can be 1 week, 1 month, 2 months, 3 months, 1 year. They can see if they can improve as they are studying. So then, of course, there needs to be a presentation. So the path from A to F is not necessarily like continuous. The teacher can choose the approach it wants. If it wants a shorter learning plan, it can skip some phases. And presentation and reporting is mainly proposed to assess a theoretical and practical dimension. Say the practical dimension can be from the results that the students get from the tool, and the theoretical dimension can be if they used all the steps and what they the complexity of their answer. And well, this is the learning plan that we have proposed. So we already received some suggestions, but if there is more, please share.
Can I ask something?
Yes.
So in the the workflows, is it some sort of format that is saving this workflow, like the SWI, for example?
Yes, it's a 9 workflow.
So the 9 workflow is supposed to be parsed with a specific the way to compose, or there is a tool that you can use to execute.
The dynamic executes autonomously. It loads the workflow. Yeah. There are special nodes that can allow you to export this model to be used in programming language and other more advanced implementations. So if you were really an informatics engineer, you can, in theory, train the model, export it, and use it in a service or something like that.
Can you consider using pre-trained models?
Cool.
Pre-trained models, have you considered using them? Because they are they are free, and students can use already trained models and just tune them for a specific set of images.
Yes.
And this would be interesting.
Yes, it could. Usually loading these pre-trained models, the architecture is, I wouldn't say complex, but it was complicated to read. There are some plugins that you can do. And actually you can, instead of loading just the images, you can load a model and train the model. But the process is the same. Whether you start, this would be more interesting because the classification is simple. This was like body segmentation, multi-classification in an image. That tends to become harder. And that makes sense using pre-trained models. But this was intended to develop critical thinking in students, for them to understand how to beginning to end. The next step would be that it's a very good suggestion. It's widely used. almost anybody trains from scratch right now.
Because training these ones takes a lot of time and it's expensive. I have.
These ones not.
They days to train the people. So sometimes it's better to use prepaid models that are already out there.
Depends on the volume of your problem. If you are classifying everything, like everything that can be, it can take time. These ones take 1 minute tops, not more. So if you have a very close set of categories that you want to define, it becomes very easy. You can do it end to end.
And I have another question. Besides cost, competition and cargo is free.
Yes.
Even if it is a closed competition only for the students of this school, I'm not sure that this service is free in Cairo.
It's free and you can host a private competition.
I mean private competitions.
Yes, it's free.
Yeah, they are free.
Yeah, I mean, you can actually host one. At least today you can host a private competition. Tomorrow, like you said, it's a private company. I don't know what business decisions they will take tomorrow, but today you can host a private competition with a private link that you will only share with your students.
Only for the students.
And there are some more strict access permissions in which you can actually input the email of the students, and only those
My
can.
question was, is this free? Because I'm
Yes,
not
yes.
sure.
Yes, there are paid. I think there are paid options, but for this implementation is completely. One more
Okay,
question.
yes, very much.